નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Standard 10th, Subject Science, Chapter 12, Electricity. So, dear students, today we will discuss electric potential and potential difference. See, before going to this potential difference, see that, dear students. Okay, suppose you have taken here my copper wire. See, look here now. This is the copper wire. So when you will touch the copper wire, can you get the electric shock? No. So in this one, if we are here, because here there is no potential difference. Here it will not or create any potential difference. Okay, if we are given in our electric source. So if you touch this one, then you will get a shock. Why? Because in this wire, it creates a potential difference. Okay. So due to this, you will get the shock. So that electricity is moving there. So now, what makes the electric charge to flow? Let us consider the analogy of flow of water. Okay, we will consider one more example. What is the other example you say? Suppose two water tanks will be there. We will consider two water tanks. Say, look here now. Okay, this is one tank and this is another tank. Okay, here water will be there. Okay, here we have pipes we have connected through this. So is there any creates any pressure between them or water moves here? No. Okay, consider another example. See, look here, here it is a tank. Here water will be there. And here it is a tank. So from here to here, you connected the pipes. Okay, from here to here, then here. So then water moves from this tank to this. So means it creates pressure. Potential difference from higher pressure to the lower pressure, water moves. Okay, so in this way, it creates a difference, what a pressure difference between the two ends of the tube. See, charges do not flow in the copper wire by themselves, just as water in a perfectly horizontal tube does not flow. So here how it is does not flow. Here also the copper wire also does not flow. So when it will be flow? If one end of the tube is connected to a tank of water kept at the higher level, such that there is a pressure difference between the two ends of the tube, pressure between the two ends of the tube, water flows out of the other end of the tube. For flow of charges in a conducting here metallic wire also the same way. So when you have source given light source, then the potential difference will create. See, if there is a pressure difference between the two ends of the tube. For flow of charges in a conducting metallic wire, the gravity of course has no role. The gravitational attraction has no role to play. But the playing is here, the electrons move only if there is a difference of electric pressure. Okay, due to the electric pressure difference, so that is only we are saying potential difference. We are saying potential difference. If there is a difference of electric pressure, the called as the potential difference along the conductor. This difference of potential may be produced by the battery or consisting of one or more electric cells. The chemical action within the cell generates the potential difference across the terminals of the cell. Even when no current is drawn from it, when there is no current is drawn from it, the potential difference will be created when the cell is connected to a conducting circuit is drawn from it. Okay, when the cell is connected to a conducting circuit drawn from the circuit element, the potential difference sets the charges in motion in the conductor and produces an electric current. In order to maintain the current in a given electric circuit, the cell has to expand its chemical energy stored in it. Now, we will define the electric potential difference. See, between the 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to the other. So this is the definition of the potential difference. See, what is the meaning of this here? See, for example, from here to here you make a point A and point B. See, between the 2 points in an electric circuit carrying some current, as the work is done to move a unit charge, the work is done from one point to the other. So that is we are calling potential difference. Okay. So potential difference is denoted by V. Between this one V, 2 points is equal to work done. So W upon charge Q. So therefore V is equal to W by Q. V means here the V means volt. So the SI unit of potential difference is volt. The SI unit is V. Okay. And named after Alessandro Volta. Named after Alessandro Volta. See, the SI unit of potential difference is volt. Named after Alessandro Volta. In the duration is given 1745 to 1827. In an Italian physicist. Okay. Now, what do you mean by 1 volt? See, 1 volt is the potential difference between the 2 points in a current carrying conductor. So, what is 1 volt? 1 volt is the potential difference between the 2 points in a current carrying conductors. So, that is why 1 volt is equal to 1 joule of work is done and passes 1 coulomb charge will be passing. 1 coulomb charge. So we can write 1 volt is equal to 1 joule coulomb per coulomb. Okay, 1 joule per 1 coulomb. You can write like this way also you can write. The potential difference is measured by the means of an instrument. So that is called voltmeter. So what is that is voltmeter. V-O-L-T-M-E-T-E-R. So this is called as voltmeter. Okay, then the voltmeter is always connected to the parallel series. Parallel across the points. So that you will learn the parallel series later. Okay. So this voltmeter is measured by the means of instrument, the potential difference measurement we are using. Okay, the voltmeter is always connected in the parallels. Now, here one question is given, dear students. How much work is done in moving a charge of 2 coulomb across the 2 points having a potential difference 12 volt? Okay, and you see, you know that W is equal to V is equal to W upon Q. So V is equal to W upon Q, you are knowing. Okay, that you learned. So here what is done? What is asked here? W is asked. W is equal to V into Q you have to. W is equal to V multiplied by Q. So you know that V is given. V how much? 12 volt is given. So 12 volt multiplied by, then what you have to do? 2 coulombs. So 2 coulombs. So then the answer will be, what is the work done? 24 joule. So what is the answer you got? 24. Work is the unit of work is joule. Okay, 24. Okay, students. So this is all you have to remember here. The important point, what is that? Volt 1 O is equal to W upon Q. So potential difference is equal to W upon Q, and this is denoted by V. And what you are saying? The volt you are saying that. Okay. Now we will see the circuit diagram. So dear students, what do you mean by circuit? An electric circuit is a path in which electrons move or flow from a voltage or a current source is called as electric circuit. So there are two types of circuits, you know, that open circuit and closed circuit. In closed circuit, the electrons will be moving. In open circuit, there is a cut will be there. Joint will be, what you are saying, removed. So that is why there is no flow of electric current. Now, we will see some symbols of commonly used components in the electric circuit diagrams. See, sometimes whenever electric circuit is given only through the symbols, you should know the component's name. Okay, for example, an electric cell will be there. See here, this is the structure is given, two ends, here positive and negative. This is an electric circuit, an electric cell diagram, and a battery or a combinations of cells. So here, see this one combinations will be the combination of cells. And next one is plug key or switch, plug key or switch open. So if it is switch open, like this will be there, and here there are two will be there. If the plug key switch is open and switch is closed, so this is the diagram. And next, a wire joint, so like these structures, and wire crossing without jointing, so like these symbols you have to use. So electric bulb like this or like this, and resistor of resistance, so like these structures or like these symbols, and variable resistance, so like this or like this also. So ammeter, AMMETR, ammeter will be like this, and voltmeter will be like this. So here A will be written, here B will be written. So these are the symbols of some commonly used components in the circuit diagrams. So dear students, one of the other ways it is in the examinations in examination will be asking in any sort of objective tests. So this is so important, you have to remember this one. So we know that an electric circuit comprises a cell or a plug key or an electric components and connecting wires. It is often convenient to draw a schematic diagram. You know, schematic diagram will be given to you, in which different components of the circuits are represented by the symbols conveniently used. So symbols will be given there. So that's why you should know these names and as well as diagrams. Sometimes this side will be given to you and you have to write this one, and sometimes these symbols will be given to you, so you have to use this one. So conventional symbols used to represent some of the most commonly used electric components. So understood, dear students? So these are the symbols of commonly used components. You have to remember and you have to practice also. Okay, students? So today in this, what you learned, what do you mean by electric potential and or potential difference you learned. Okay, definition of potential difference. So then one more here, this formula you learned, V is equal to W upon Q. So potential difference between the 2 points is equal to work done upon charge. So this is work done upon charge is denoted by W. Okay, then the SI unit of electric potential is difference is volt denoted by V. And next one, 1 volt is equal to 1 joule per 1 coulomb or 1 joule per coulomb. Okay, these are the things or these are the points you have to remember. Okay, thank you, bye bye. Thank you for joining us.